Hello beginners, this is a demonstration of lightning point circuits. As you can see here, this is a 10 amps circuit breaker, 5 amps, 10 amps, 5 amps, 10 amps, 5 amps. This is the neutral copper rail, and this is the earth rail. As you can see, the earth, there is no connection from the lightning point circuit to the earth because lightning points consumes low power, so it's difficult. You can sustain injury or die from shock that comes from a 1.5 or 1 mm wire, because the current that flows through a 1.5 mm or 1 mm wire is low. It's not more than 1 amps. So the shock that you receive, you will feel it. It will affect you, but it doesn't lead to injury or death. That is why lightning point circuits are neglected when it comes to earthing. As you can see from this 10 amp circuit, you see a red wire, 1.5 mm wire, going to a 3-gang switch. As you can see, this switch, this is the common. It goes to the 3-gang switch. It goes to one common. From one common, it is linked to the other common. From the second common, it is linked to the third common. From the third common, it is linked to the fan regulator. This here is a ceiling fan. From the common of the switch, it links to the fan regulator. As you can see, the supply do not come to the lightning points. The supply from the circuit breaker, where electricity is supplied, does not go to the lightning points. It goes to the switch. And the common and the L1 or L2, this L1 and L2, if you connect to L1, when you flip the switch upwards, the lightning point will light up. When you flip it downwards, the lightning points will be turned off. So when you connect to L2, when you flip upwards, the lightning points will be turned off. When you flip downwards, the lightning points will be turned on. So anywhere you can take connection from either L1 or L2, depending on what you want. L1 and L2 are not connected together. L1 and L2, L1 and common, L1, L2 and common are not together. The common is separate. When you flip the switch, you connect them. As you can see, from L1, you have picked another wire down to the lightning point. This wire will control this switch. When you flip, you turn on. When you flip, you turn off. As you can see, this lightning point again, another wire has gone to it, live wire, to control this lightning point. As you can see, this live wire goes down to this other bulb, making it 3-gang switches to control these 3 bulbs. Then this is a fan regulator. As you can see also, the common goes here, and another live wire is connected to the fan to make it pick electricity from the common of the fan regulator. As you can see, the neutrals are looped together. As you can see, the neutral from all the lightning points and the fans come together till they go to the copper rails. The neutrals are wired together, but the live wire from the circuit breaker comes to the switches. It doesn't go to the lightning points. That's what you know as a beginner. The live wire from the circuit breakers will always go to the common of the switches, whereas to the lightning points you take from either L1 or L2, so that when you turn on the switch, the lightning points will turn on. When you turn off the switch, the lightning points will turn off. This is how make and break is achieved using this in a conduit system. What I'm telling you is what happens inside a conduit pipe. As you can see, if you can imagine it and understand it in your imagination, so you can manipulate it anyhow you want. But this is for you to understand how it goes. As you can see, this is one circuit. This point all are one circuit. They are one circuit in that when you cut off this, when you turn off this circuit breaker, they are connected in series. When you turn off this circuit breaker, everything will stop working. If you turn off this particular circuit breaker that connects to all of these, nothing will work again. All these are connected to one circuit. This is another circuit. Here, as you can see, the neutral is connected to all the lightning points and to the fan. This is a 1-gang switch. This is a 1-gang switch. In between is a fan regulator. This is a 2-gang switch. As you can see from the circuit breaker, the supply comes to the common, the common. As you can see from the L1, it goes to these lightning points, so that this particular switch will control this lightning point. As you can see from the top of the fan regulator, it connects to the supply, so that when you turn this regulator around, you can get contact between this one and this one. As you can see, this other lightning point is connected to the L1, so that to make it uniform, they are connected to L1 so that it will be uniform. All of these switches will be turned on by flipping it up and turned off by flipping the switch downwards, so that they have uniform orientation. As you can see here, this lightning point is also 1-gang. This is 2-gang switch. This gang controls this lightning point. The second gang controls this lightning point. Whereas all the neutral comes from the copper bar and joins together. All the neutrals are connected together, but the lightning, the supply from the circuit breaker comes to the switches. This is another circuit, because when you cut off this supply from here, all these lightning points and this one will be cut off, whereas this one will be working. If you turn off this circuit breaker, this part will be working. This circuit and this circuit are in parallel. They are in parallel. When you cut off this circuit will be working. When you cut off this circuit, this other circuit will be working. This is how electrical installation is being done. This is for lightning points. It's very easy, very easy. Subscribe, like the video. This video is for you to understand electrical installation. Do not do electrical installation without the guidance of a professional. As you know, electricity is dangerous. You have to be very careful. Before you do something, make sure you understand what you're doing.